So the talk today, I will talk about what can Lagom do for you. And I had the idea of giving that talk when I was at Scala Exchange last year. And I was talking with many people building microservices using Akka persistence, and Scala, and so on. And I realized that there are a lot of people building microservices, and they don't know what Lagom offered to them. So I said, okay, maybe there are some opportunity here to build a talk on that. And so the agenda will be, I will give a brief introduction of Lagom and how our vision, how you go from monolith applications to reactive microservice. The core of the talk will be actually about the Lagom persistence API that is built on top of Akka persistence and Akka clustering. Okay, and then I will also talk about I will show the Lagom service descriptor during the demo, but I will not concentrate much on that. That will be probably the topic for another call. So just a small question, just to have an idea. Who is familiar with Lagom? Okay, some people, yeah. And who are familiar here with Akka persistence and clustering? Okay, so that's good because, well, most of people know how is Akka persistence. I will not give an introduction to Akka persistence, so I assume that you guys understand that, know how it works. So the thing is that Lagom builds on top of two main technologies that we have at Lightband. The first one is the Play framework, and the second one is the Akka persistence. So it's a framework built on top of another framework, and it's, I would say, prescriptive to some specific things. It's built for building. It's conceived to be used for building microservice, and as you see, it's built on top of Play framework, but you not see actions or essential actions like we have in Play. We have another layer on top of that, which is the service descriptor. And you understand why we have that later on. The most important thing for me, I believe in Lagom, is the persistence layer, because there we leverage Akka persistence and cluster sharding. And I hope you guys will get a good understanding why that's important and why we are doing that. We also have some dev tools, some development environment to help you doing development. And it's much like Play, that you start to do a run and it starts the application and it keeps running. You change your code, it recompile and reload the application. But Lagom is a little bit more than that, because usually in Lagom you have 1, 2, 3 models. And you also have like a Kafka that will start a Kafka server that is started for you. If you're using Cassandra, you have an embedded Cassandra that started for you. In my demo today, I use a JDBC version of the JDBC version of Lagom. I mean, the persistence API for JDBC, not for Cassandra, just because I like it very much. I like Slick, and it's used based on the Slick as well. And I think it's easier for demo. So, who knows what is that? So, obviously, that's a monolith. So you see it's a big application taking all my slide here. And those forms here behind, inside, they represent parts of your different domains that you have put inside your application. And that's how we have built application for years now. And what they do is that those many different parts of application, they communicate with each other. They are tangled, and those calls that we see here, so the triangle call, it was supposed to be a circle, but it's now an egg, kind of failing egg anyway. So the triangle calls the egg, and it's all in-process calls, no? So it's just an interface that you call it, and so on. The problem with this kind of approach is that, those applications become too big and hard to manage. And on top of that they all write to one single database. So it's very hard to scale that out. I was working some time ago for the Flemish government, and we had like a huge application. Then part of that application was doing many other things, but one thing that they were doing, they had some part that was used to do some calculations over the roads in Belgium, in Flanders. And lots of other applications were calling that application just to be able to do those calculations. So whenever I need to do a calculation of geographical, some geographical calculation, I had to call that application. And that application was failing because of that. Every other application was calling that application just because of that calculation, while that application was also responsible for doing some other stuff. So what we did there is taking that part of the application and make it an apart service. No? So that's the idea when you have this monolith. At some point, you have to split them. But what people will do very often when they split their monolith is that they create small applications that now communicate between each other via REST call or RPC calls. There are actually two problems here. The first one, it's actually kind of obvious, I think, is that when you create those different applications, they are running different process. Now I'm calling over the wire one application from one to the other. And by doing that, I'm adding latency. But that's expected, no? What is less obvious from this is that you are creating here a temporal dependency. By temporal dependency, I mean when the triangle application needs to call the egg application, well, if the egg application is not running, the triangle application is broken. So it depends. It not only depends on the service or the other one is provided, but it also depends on the fact that the other one must be running. No, and in that case here, if the circle or egg one gets crashes, actually the whole your system will be impacted. Either they will be failing or they will be partially operational, because the triangle depend on that, the square depend on that, the pentagon depend indirectly to that, and so on. So once the circle goes, everything degrades. So the idea how you solve that is how do you cut that temporal dependency is by not necessarily calling each other via REST calls or RPC, but by publishing data to some broker and consuming from there. So at that point, the circle or egg application can be down, but the events that were published on the broker are still there, already there, and I can consume those events later, even if the circle application is being redeployed. So that's the whole idea of how you go actually from, I would say, a monolith to we call it a microlith, so actually microservice, but still very dependent on each other, to a reactive microservice where you cut that temporal dependency. But how we do that? Ah, yeah, I forgot that. And here you can also, you can also do that here. You can, because now you have separate applications, you can scale them up according to their needs. So you can have many instances of a triangle or a square and so on. But how will we achieve that? We achieve that by focus on event first design. Make sure that every mutation in your system can be represented in terms of events. And that's why event sourcing is so important. So the Lagom Persistence API main focus is to help you on that. And it embraces the concepts of event source and CQRS. So in command query responsibility segregation, you have the command side and the query side. And we'll have a look on those two things and what are the most important problems that Lagom is solving for you there. So on the command side, what Lagom solved for you? First, the single writer principle. I will come back, I'll give more detail on that. Persistent actor passivation. That's actually, there are two features that are in cluster sharding, Akka cluster sharding, and Lagom leverage that, and that's the important aspect. Then there are two subtle bugs that you can write, write yourself if you are doing, if you're using Akka persistence directly yourself, and I will explain what that is. So back to the single writer principle. If I have one node application, so I'll show you in a while how does it happens in Lagom, but you have your model that we call a persistent entity, and that thing will run inside an actor. And we know that in Akka, if I have if I initialize an actor, I cannot initialize another actor with the same path on the same location, so it will fail. And so if I have one single node, I'm kind of safe because I can guarantee that that instance is only running once in my system. But if I have a cluster and I have many nodes, I must make sure that for a given entity identified by ABC, let's say that's the idea of that entity, I only have one over my cluster. And that's what cluster sharding will help you to achieve. And another thing is that if I have a command that I have to send to that given entity, and I need to, first the cluster shard will know where that entity is living, or where that entity must be initialized. And if I need to send another command to it, I don't know if I don't need to care about if it's already memory or not. The cluster shard will take care for that for me. And what happens with an actor that you bring into memory? If it doesn't crash for some reason, and if you don't shut it down for yourself, it will stay in memory. So what Lagom will do is that it has that, that's part of cluster sharding, but Lagom has a timeout. If the entity, it's idle for some time, it will passivate itself. It's okay, I'm not receiving any command for now, so I will just stop. And the cluster shard will coordinate that. It's not just like I will shut down, because if you have a command coming at that moment that you're shut down, what will happen with that command? It will fail because the actor is being stopped. Well, we don't want that. So the cluster shard will kind of, the shard region knows that that entity is being shut down, and then will buffer that command. And once the entity really finishes the shutdown, it will bring that entity back to deliver the command. So those are things that the cluster shard are solving for you. And that's why in Lagom, you have the persistence entity. It runs inside a persistent actor. That's pure Akka persistence. But we bring together the persistence, Akka persistence plus Akka sharding, Akka cluster sharding, to create that complete solution. And that's just work like it is. Like we don't have to do that yourself. Of course, it's not hard to do it, but since we can just build that for you guys, we have it. That's it. So now I will give you an explanation. What are those two protections of these two kind of bugs that we have here? So what it really happens is that a persistence entity will live inside a persistence actor. Okay, we take care of that. Then there is a command that comes in, and it goes over a validation. I have to decide if I can apply that or not. Then an event will be emitted eventually if the command is valid. And then it is applied to my state. That's a very important thing, because later, after being applied, it will be persisted. Why? Because people, I have seen that happen before. People persist the event, and then they apply the event. But when they apply the event, they realize that they forgot to declare event handler for it. And then what happens is that that event cannot be applied, the actor will fail, but the event is persisted. And when you reinitialize that persistent entity again, it will replay the event, and you will again fail because there is no event handler to handle that event. So you first need to apply the event and then persist. It seems like obvious, but people do make that mistake. And when you're using Akka persistent yourself, I have done that before, and I have seen that happening. And Lagom will also take snapshots for you. And different than in Akka persistence, you have to yourself decide when you persist a snapshot. In Lagom, you just have a configuration where you say every 100 events persist in a snapshot. Another subtle bug that happens, and my friend Nico was tweeting about that another day, is when you persist an event and then you make a snapshot, make sure that you have already applied that event. Otherwise, you're persisting, your snapshot is from your previous event. Well, he probably made that mistake as well, as many of us have done. And Lagom kind of solved that. A nice thing is that I was not here when Christopher was talking about the future of Akka, but he was probably talking about Akka typed. So the Akka team are working now on the Akka persistence typed, and it's those things are also solved there, because the Akka persistence typed take more or less the same approach as Lagom is doing. It's like it gives you the means to declare your command handlers and your event handlers, and it takes care of the correct ordering of when the event is emitted, it's applied, and then persisted, and then the snapshotting. So this, you cannot make that mistake anymore in Akka persistence type. You will not be able to make that mistake, and you cannot make that mistake in Lagom. So those are two things that the command side is solving for you, plus the sharding. The query side, so to generate views from my events, I'm talking about one single service, okay? So in my service, I have that entity that are producing events on my journal, and from that journal, I will generate some views on my model. So there are a couple of things there. The first thing is the sharded tagging, which allows me to have distributed read-side processor. So what is a read-side processor? It's a kind of processor that you define that will consume your events and generate views from that. And Lagom will, by using these sharded tags that I will show you in a while, what that exactly is, it allows us to have distributed read-side processors. We have some facilities for developers if you want to. I want to write some stuff in Slick, for instance, in a JDBC database, which is that's the case on my demo today. I can let Lagom create the table for myself. And most important, and that's the main reason why I choose JDBC, because I like it very much, how these things work, is that Lagom does the offset manage for you. What does that mean? What does that mean? Is when I have an event of streams, each event from my journal has a sequence number, okay? And Lagom starts to consume that, and for each event it knows, okay, that was offset that much. And then I give that event to you, so you do your stuff. You do your database operation, and what you give back to me is not it's not yet executed. You give back to me a Slick DBIO. That I will take that DBIO, I will take the offset that I know, the one that belongs to that event, I create another DBIO, I compose those two, and I execute on the same transaction. What does that give is exactly once delivery. So on the read side processor, when your operation database succeeds, it succeeds together with my offset. If it crashes, next time I restart it, and I will take an offset that you have never seen before, or you have seen but your transaction failed. So the offset is managed on the same transaction, and that's a good thing. And you have this kind of backoff supervisor for streaming. It's called restart source. It's the same principle of a backoff supervisor, and when it fails, it restarts after some time. So that's all there for you. And then just some example what is the sharded tagging and the kind of problem that people have with that. So when you persist events, you can tag your events, and that's the way we have in Akka persistence query to later say, okay, I want those events. I want all the events that has this tag. So in the example I will give today, I have this account. I will use like a very simplified bank account thing, and so my persistence ID, Lagom will create a persistence ID that is the name of the entity, pipe, and the real ID of that entity, okay, ABC. And then it will add tag on my journal for that. So I'm just taking the case here where I'm not sharding the tags. And then what will happen here is that if I want to consume that, I will use Akka persistence query, and it will say, give me all the events in order for account, everything that is tagged with account event. What's the problem with that? It means that I will have a consumer that will consume all the events from my entity. So if I have here a journal, and I have three kinds of entity, three entities, 1, 2, and 3, and the events are in the journal like that, they are interleaved. Now I have one consumer that has to consume them all. And what will happen if I have them in a cluster? If I have many nodes, I have my read side processor being started in three different nodes and doing exactly the same, consuming all the events over and over again. That's not what we want. And what people do usually when they are doing that themselves, they say, okay, because I want to have only one consumer, I will put it on a cluster singleton. And as cluster singleton in Akka, you make sure that it makes sure that there is only one instance of that actor over your whole cluster. And then what people do, they create a processor themselves, and they say, okay, that has to be a cluster singleton. And so you have one node in your cluster that is consuming all the events. But what we really want is to separate a little bit those events, not necessarily having one processor per ID like here, but I want to create a logical view over my journal. And I want to be able to identify them in a different way. So what Lagom will do is they will shard the tags. So I can say how it's done. You basically say that's my entity, that's my event, and I want and I want 10 shards. So when Lagom persists the events, it will take the real ID of the event, so not the one that is persisted, but the real ID of the entity. In that case here, it's ABC. It will take the hash code, and you do, let's say, model 10, if you ask it for 10 shards. And then model 10 will give you from 0 to 9 numbers that will be appended to the event. And Lagom is managed that for you. Then Lagom will say, okay, when you have one single node, it will create 10 processors. And each of those processors will consume one specific tag. So I achieve that. Now, instead of having only one consumer, I have 10. And if I put another node, if I was talking about one single node, if I add a second node, it will be distributed. I have one node consuming 5 sharded tags, and another node consuming the other 5 shard tags. I increase my cluster, and they get distributed. So that's there for you. You can have a look on the code and do that yourself. But I'm not saying that it's rocket science, but there are some nice tricks there to make it really happen. For instance, how can I know if I am a node and I start up, how can I know which shards tags I have to consume, which processes I need to start? So Lagom take care of that for you. So I think it's one of the most powerful things in Lagom is that we take care of the persistence, but we put it in the context of cluster sharding in one side, and we take care of the read side. On the other hand, we take care of the read side, and we make it possible to have different processors at the same time by sharding the tags. That's good because it's time for a demo, and my time seems to be okay. So how it looks like? I will start with my account entity. I won't do live code because I suck on that. It's really bad. And instead, I will just go over the code and explain. So this is a persistence entity Lagom. So that's in terms of DDD, we call it an aggregate. And you just, that will run inside a persistent actor, okay? So, but you don't see actor stuff in there. You see a little bit, but it helps you focus on your domain, and it's about define the state. In the case here, it's an account, and I have account commands and account events. And then I have an initial state. My account starts with 0 balance, and then I have a command. I deposit something, then I persist that event, and I reply. And on the withdrawal, I have to decide if I will go below 0. If I go a negative balance, it's not allowed, so I can reject the command. And then I have my event handlers, what I do when I receive that event, the deposit event, and when I receive get back the withdrawn event. What's important is maybe it's not so obvious, but I was saying that before. When you say here, then persist, you're not yet persisting. You're telling me what you want to get persistent. What I will do behind the scene is, okay, that's the event, good. I will apply it using the event handlers you gave to me. And then I persist it. What happens if I apply the event and it fails to persist? So I applied the event on my state, but I couldn't persist it. Is that important? Do we care about that? Well, actually not, because if you try to persist something and the database is not there, for instance, your actor will blow up. And then that state will be gone. And because you are inside an actor, because that thing will run inside an actor, you're protected. Nobody can see that state in the meantime. You apply it, you have some state that was mutated in memory, but you fail it to persist, so that goes. So at the end, it only counts once it's persisted. Then it becomes a fact. But we apply it before persisting to guarantee that the event handler is there. So here I have everything defined. I have for each type for each data type, I have here the account. It also has a JSON serializer. The command has a JSON serializer, and so on. The events, that's an important thing. It has to, my base event implements this aggregate event. That's where I have to define that tag. That's how Lagom will tag your events. And when doing that, I'm using that sharded tags here, and I'm using that number of shards 10. That's how I will get the events sharded, okay? So when you define your events, you say, okay, and I want for that entity, I want 10 shards, and so on. And here are the serializers for my events and commands, and it will be wired together in your application. So, loader, yeah. So here is where you wire your application. So the Scala version of Lagom, you use MacWire to wire everything together. So you have those components. So you build your cake with that. And then at some point you have to declare to Lagom your persistence in the persistent entity registry. You say, okay, that's an entity that I want to be run inside an actor. I have also here the serializers. I have here the event processor. And the event processor is just a small class where I take a repository, a report, account report thing. I teach Lagom how to create the table for me here, and I have the event handlers. Whenever I get a deposit or a withdrawn, what I will do, I will increase my report. I'll show you what is that. It's just a small class that I have here for demo purpose, where I have the account number and I have a transaction count. Doesn't matter if it's deposit or withdraw, I will increase that counter to say, okay, I have so many transactions on this account. That's the kind of report I created. And the rest is just slick code, okay? So what, no, this one. What this method is expecting is you return here, you must return a DBIO. A DBIO here, where you put your operation. And I will take that DBIO together with the offset one, I will compose them and execute on the same transaction, which will give us exactly once delivery, unless you remove things, the offset tracking. And then I have this service here, and I will start to show now the service descriptor part. It will become more interesting on the next part of the demo. But that's a trait where you define your external API. And for each method I have here, I can request the balance, I can request the account transaction, I can deposit money, I can withdraw money, and I have this service call that I have to implement later on. And then this is equivalent to a play routing file, okay? I say API account, here will come the account number. You see that there is a column there, and I can ask for the balance. Lagom will try to infer what you want to do here. For instance, that method has no payload, but it does return something. So when I define as a path call using a service call that has no payload but returns something, that will be a get in REST terms. If I have a call that does pass a payload, then it will be a post, and so on. So that's how it works. And you see in a later example that you can also do WebSockets. Okay. So let's go for the demo. So you start Lagom just by doing run all, and please just work now, demo time. And I have here, I like to do, I have here a file. Let me see if I'm on the right place. No, account, demo. Ah yeah, by the way, I have here Docker Compose. I have here Postgres running, and I will connect to that. I want to connect it before it started. Yeah, perfect. Here I'm connected to Postgres, and you see there is no table there, but Lagom is starting. And what we'll see is that it's now I have the tables created by Lagom. And for my demos, I like to have a file like this one that I will source here, which I can have some functions that I predefine for the demo. And I will show you how it looks like. That will make a post on Lagom passing some payload. So if I say here, account, I will deposit 1,000 euros on the account identified by ABC. Okay, so it goes inside Lagom. The entity take that and create deposit. So what we'll have here behind the scenes, what Lagom have done is first. My account report was created here on my table. No? My account report was created. Let's see what we have there. Select from. So now I have that's the report I have. I have one transaction. If I put another one, I have two transactions. That's my read side, no? That I have my processor producing that. But the most important thing is that what is interesting for us is that Lagom is taking care of that as well. Lagom is tracking that for the read model, name it account report. For the tag, that one with the tag, the tag account event 4 sharded with the number 4, I'm on the sequence offset number 2. If I create here, no, not that one. Yeah, no, it's this one. I have tested it before. If I use the ID ABCD, I will go on the same shard. I will have the same sharded tag. So this one, I create a new account, I put 1,000 euros on account ABCD, and on my offset, I have only one entry. Why? Because the tag of this account is the same. But here on that one, I have two read sides. So I have now two read sides being processed by the same processor, because those two IDs are being tagged on the same shard. Okay? And of course, I can add more. And so I will stop this one, and I will let it start here in the background. And what I have done now is I increase my account serves and I create a topic. So 10 minutes, okay. So before I was only on my service descriptor, I have only those calls, service calls, like REST kind of thing. And now I have the topic. And the topic is actually the broker API in Lagom. And the implementation of that, that's the service. I have the implementation. And I have another service here. So I have now two services running in Lagom. And that other service, it's a very simplified thing that I did here, but yeah, I will start by the loader. So the loader on that other service, it declares a service here, the stream service, and it declares that it wants a client on the other service. That's my original service, okay? The account service, where now I have a topic. And now I ask Lagom, and that's a macro in Lagom, like take that trait and generate a client for me. And Lagom will know where that other service is running, because Lagom is take care of that, okay? So, and I will inject that here on my service implementation. So that is my first service, account service, where I ask the transactions, which is a topic, where I can subscribe, and I can say at least once. And I will just take the message coming there, and I will print it. What will happen here is that in one side, on the account service, Lagom will see that you declare a topic. Let's have a look on how we implement it. That's a topic producer where I'm saying, okay, I want to teach Lagom where it has to, how it has to set up this Kafka topic. And I'm saying, okay, go to my persistence and registry, take an event stream of all the events that I have there using some tag that will show up here using the sharded tags. I convert each event to a string and I put it in Kafka. So Lagom does that for you. And then the other side, your other service can subscribe to that. What happened here is that because I was just doing println, I have, that's the account stream service that is printing that, okay? So it's one service pushing things in Kafka for you, the other service is consuming from Kafka and printing on the standard output. But the next thing that is happening here is that thing. Now I have two offset tracking, one for my own read side and one for the topic producer. That is Lagom thing. It's doing that for you, but it's the same kind of infrastructure, I would say. If I have, I will put here another entity. What will happen is now I have one account report, two account reports, and two topic producers offset tracking. What does that mean is that when I have, because I choose a sharding of 10, it means that I will have in my single node, I have a single node here, 10 process for my account report and 10 process for the topic producer. I increase my cluster, I put another node, both are distributed. Part of my processes will go to the new node, both for the account report and for the top producer. So we spread the load as we go, as we increase the size of our cluster. So the next part of the demo, and I think I still have some time, is, how I call it, pub/sub, yeah. Let's see the code. What I did here now is I increase my, I add one more method on my service descriptor. And that method has something different. Here is, I get an account number and my service call has no payload, but it returns me a source of string. When Lagom sees a service call returning a source, it will translate that to a WebSocket. So what I did further here is account entity. There is another thing in Lagom that I'm using now. It's the pub/sub, which is based on Akka pub/sub as well. And it's an in-memory thing, so there is no persistence here. I put something on the pub/sub, it will be distributed in my cluster to everybody that subscribed to it. So what I'm doing is, after persisting, I put some message in the pub/sub. And I say there is a channel here where for that ID, and if you subscribe to it, you see that happen. But that's an in-memory thing. That's not, if you're not subscribed, if you didn't subscribe to it, you'll not see it. So you must have subscribed when the event happens, and then you see it. So I'm using that to demo the source thing, the WebSocket. So I have a look. We'll have a look on the other service, the stream service, to show you that I also add here another stream method that's exactly the same as the other one. It takes an account and it returns a source. But what I'm doing here is when I call the account stream service and I pass an account number, it will call the other service. And what this method will return me is a service call. Well, not this one. Yeah, it's hard to see here. No, maybe not. It returns me a service call that returns a source. Here, because I'm in Scala, I'm not even seeing that there is a WebSocket going behind the scenes. I'm just working with Akka streams. So I have this, I get back a future with a source in it. So I map, that's my source. Let's see. The type here is a source, okay? So it's maybe not too big for people behind in the room, but that's a source, and I'm just transforming that source and adding, prepending, streaming on it. So what will happen here is, let's go back here, no, here. Now I will connect with a WebSocket client to that stream thing. Maybe it's better to do it here. Almost finished. When I put a deposit, it should show up there. But if, the thing is, here I subscribe to ABC, but here I put an event on DNF, so that's why it didn't show up. So, boom, voila. So now what is happening is, I send a command to my account service. It emits an event. After persisting, it put on the pub sub. The account service expose that pub sub via WebSocket. The other servers take that same WebSocket and expose it again by adding this streaming prepending that. But on the code level, I'm not even seeing whatever WebSocket infrastructure. I'm just work with Akka streams. So that's more the service descriptor functionality in Lagom. And actually, that's everything I had to show today. I hope I will give another talk another day, only focus on service descriptor. But I hope you guys have already a good idea of how it works and what are the nice goodies that are there for you. I think we still have some time for questions, 2 minutes, but we can, now it's break, so we can stay here, I think, and have some questions. Thank you very much. Yeah, we have a question here.
Yeah, I'm curious why it was based on the play framework.
Yeah. I don't know. I was not there when it happened. Well, I think that you could have done the same. One thing that is for sure, it takes from play the same kind of developer experience that you start and you recompile your code. You have that service call API that is, you see that I can generate a client for that. And that's why I'm not using action directly, but you can go one level down and use play actions. And I believe that for application development, it's easier to use Akka play actions than going bare bone one level deeper. Maybe I have a better, one more information that is probably the reason why it was like that, is that originally Play had as backend Netty. So we need to, instead of building another layer on top of Net, we built a layer on top of Play. But now Play is moving to Akka HTTP and Lagom as well. So now we have service call, Play actions, Akka HTTP. Yeah? So eventually, And that's things that we are working now. And whatever I say now, it's not a promise, okay? But there are a couple of things happening in Lightband right now. One is the akka typed and akka persistence typed that I was saying it's very similar to Lagom API. And there is also akka gRPC. We have already released, I think, 0.1. It's very experimental. And at some point, I believe you just take an akka gRPC server and put the Lagom persistence API behind it, or the Lagom or the akka persistence typed API. So we'll move things as we go and as those other technologies become more mature. And then at some point, maybe you not choose Lagom, but you choose akka gRPC plus persistence with sharding. So we are puzzling there. Those things has to get more mature, and then we'll see how it will evolve. Yeah, another question there. So the question is if akka gRPC is working correctly, and if it's working correctly in Lagom. Well, it's not yet working in Lagom. So we have some experiments. There are some people work on that, but akka gRPC it's also very initial phase. Huh? So it's not out yet. It's out. It's open source. There is version 0.1, but it's not. I would say it's not yet production ready. There are some things in Lagom that we still need to solve, and I didn't show that because I didn't concentrate much in service descriptor. But first thing is that if you see how I generate a client, and it knows where is the other service. So there is behind the scene, there is a service locator. And at that service locator, we also have circuit breakers. So if one service is down, I can go, it will close it will open the circuit breaker. That is not yet there for akka gRPC. And that is when we bring akka gRPC into Lagom, we have to solve those problems as well. Because I will not generate a client like I did here. I will generate a gRPC client from protobuf definitions. So I have to, so that part is not yet there. So we are working on that.